Let's do it. Hey guys, in this session, we answer exam questions associated with measurements.
Okay, so we are still busy with the topic of measurements. We are answering exam questions associated with the topic. So let's get started. All right. Now we are doing question 8. Question 8 says that in the diagram, a lid with a hemisphere, okay, so a lid with a hemisphere form, okay, seals an open cone. Let me just use the other highlighter. Okay, so they say that a lid with a hemisphere form seals an open cone. Okay, what did they mean by the speak English? So they're saying that we have an open cone. Okay, open cone. Okay, we can see that this is the cone. Okay, so the cone is open at the bottom, and to close the cone, we use a hemisphere lid. Okay, you can see that this lid has a shape of a hemisphere. Now, a hemisphere is basically half of a sphere. Okay, so this is simply half of a sphere. We call that a hemisphere. So the hemisphere is a lid to close this open cone, right? So that is what they mean. Let's continue. Okay, so they say that the slant height or the slanted height of the cone is 13 centimeters. Now this is the slanted height. This one is 13 is given, and then the diameter of the cone and the hemisphere is 10 centimeter. We know that the diameter is 2 times the radius. So if the diameter is 10 centimeter, we know that the radius is 5 centimeter. The radius is 5 centimeters. Okay, and then the height of the cone is h centimeters. Okay, so the height is given as h. So this is the height h. Okay, and then they are kind enough to give us some formulas. So they give us a formula of volume, formula of surface area, formula of surface area. But now it is our job to figure out which volume belongs to the cone and which volume belongs to the hemisphere. Okay, let's try and figure that out. Okay, now we know, let's think about the hemisphere for a moment. We know that the volume of a full sphere is given by 4 thirds or 4/3 pi r cubed. This is the volume of a full sphere. Now, the volume of a hemisphere should be half of the volume of a sphere. Okay, let's see. So be half times 4/3 pi r cubed. Okay. Now, basically, what will happen is the 4 will be divided by 2, and then we'll get a value of 2. Okay. So we'll end up with 2/3 pi r cubed. So this is the formula for the volume of the hemisphere. Now, with that being said, we can see that this formula matches with this one. Okay, so this now can be said to be the volume of the hemisphere. So hemisphere, okay, and then just write H for hemisphere. Okay, we can write the whole word this one. Hemisphere. Okay, so this is the volume of the hemisphere. Okay, and then if that is the volume of the hemisphere, by elimination, we can see that that means that this is the volume of the cone. Okay, this is that of the cone. But then even if we tried to figure this one out first, we know that if we are dealing with stuffs like cones, which are pyramids, by the way, because of this point, the apex, they are pyramids. Now we know that the volume of any pyramid is given by half, not half, sorry about that. It's given by 1/3 or 1/3 times the area of the base times the perpendicular height. Okay. We spoke about this. We said that the volume of a pyramid is given by 1/3 times the area of the base, and the base is a circle. We can see that. So it will be pi r squared, and then this will be multiplied by the perpendicular height. And in our case, the perpendicular height is equal to h. Okay. So we can see that still this one matches with this one. Okay, so we can see that that is the volume of our cone. Okay, let's figure out the surface area formulas. Let's get rid of that guy, and then get rid of this one. Okay, now we know that the surface area of a sphere, a full sphere, is given by this guy. Surface area is 4 pi r squared. Okay, and we know that a hemisphere is basically half of a sphere, so the surface area of a hemisphere is half of the surface area of a sphere. Okay, with that being said, we can see that 4 will be divided by this 2, and then we'll end up with 2 pi r squared. Okay, so this is the total surface area of a hemisphere. Let's see. Okay, now this is the equation that matches with this one. Okay, now we can conclude that this guy is the surface area of a hemisphere. Hemisphere. Okay. That makes this guy to be the surface area of the cone. All right, cool. Now let's answer questions. Okay, okay. Let's answer the questions. Now the question that we are asked is for us to determine the height of the cone. So they want us to determine the height of the cone. In other words, they want this h. Okay. Now hopefully we can see that this height that they want is perpendicular to the base of the cone, right? So we have a 90-degree here. Okay, it's perpendicular to the base of the cone. And with this, we can see something very interesting, that we have a triangle, a very special triangle that is forming here. Triangle like that, and then triangle like that. Now, this triangle is a right angled triangle, or a 90-degree triangle. Now, we know something that is very interesting about these kind of triangles. There is a relationship between the sides of these triangles, and the relationship is what we call the theorem of Pythagoras. Hopefully you studied this in grade 8 or grade 9, somewhere around there. So let's say we have a 90-degree angle, or a right angle triangle of the sort, and this side is side C, this is side A, this is side B. The theorem of Pythagoras states is that the hypotenuse squared is equal to one side squared plus the other side squared, like this. Okay, now if you want a different side, let's say we want A, we will simply make A the subject of our formula. So we'll say that A squared is C squared minus B squared. Okay, and then we can therefore say that A is equal to the square root of C squared minus B squared. So this is how we'll get the value of A. Okay, now the very same principle, or the very same method that we are talking about in this triangle, is what we will use to determine the value of h. Okay, we will use the theorem of Pythagoras. Now let's do that. So the first step is for us to write the theorem of Pythagoras. So we can say a squared is equal to the not the square root. We can say that is equal to c squared minus b squared. Okay, just for just for reference purposes, you can only use these alphabets if you draw a small diagram on the side and then annotate or label that diagram so that the person that is marking your work knows exactly what you're talking about. So what I'm saying is, before we can even start, what you can do is you can draw the small diagram on the side, and then you can put your B, your A, and C, and then you can use this formula because the marker will know what you are talking about. Okay, so we will say from there, it means that A is c squared minus b squared under square root, and then a is our h. Okay, c is our 13, so we have 13 squared minus 5 squared because b is our radius, and then from there we can we can get our value. Now if we put this in our calculator, we see that the value that we get is 12. Now that means that our A or our H is 12 centimeters. Okay, so our height is equal to 12 centimeters. Okay, and then the follow-up question 8.2, they said that we must write down the height of the container. In other words, the height of the whole object. Okay, okay. Now we have to be very careful, okay, because we know that the 12 centimeter is from the apex or from the top to this point. Okay, so basically it is this distance. This is the 12 centimeters, and then the complete height has to be the 12 centimeter plus the distance from there to the hemisphere, okay, or to the bottom part of the hemisphere. Now we know that from the center to any part of the hemisphere, that is the radius. Okay, so we know that this little distance is 5 centimeters. Now the total height of the shape will be 12 centimeters plus 5 centimeters, which will give us 17 centimeters. Okay, so the answer for this question will be 17 centimeters. Okay. And then they ask us to calculate the volume of this container. So the volume of the whole container. Hey, my diagram is a complete mess. Let me just clean some things. Get rid of that. Get rid of that. Okay. Get rid of that. Okay. So we know that the R is 5 centimeters. We know that the R is 5 centimeters. We know that this height is 12 centimeters. Okay. And yeah, so they want the volume of the container. So they are looking for the volume of this container. So the volume of the whole thing. Now you will agree with me that the volume of the whole container is basically the volume of the hemisphere plus the volume of the cone. Okay, so I will say that the total volume is 2 over 3 pi r cubed plus 1/3 pi r squared h. Okay, and then I can just substitute my values. So the pi, and then our radius is 5. We established that long time ago. And then 1 over 2 pi 5 squared. So it's 5 squared, and then the height of the cone is 12 centimeters. Okay, let's see what value we get. 2, 3, 5, and then 5 cubed, and then plus 1 over 3 pi, and then this 5 squared times 12. And value to get, I get a value of 575, so we get 575,96 centimeters cubed. Okay, because we are working with volume. Okay, so this is our answer for A1. Okay, this is our answer for 8.3. So our answer is 575.96 centimeter cubed. Okay, and then the follow-up question, the following question says that determine the total surface area of the container. Okay, the total surface area of this container. So the total surface area of the whole thing, the whole shape. Okay, let me just remove this. So remove this guy. Okay, now the surface area of this shape, we have to be very careful now, because it is very tempting for us to be like the total surface area is basically the surface area of the hemisphere plus the surface area of the cone, but we have to be very careful, because in this case that is not the case. Okay, so let's consider the hemisphere first, this part. Now the hemisphere is that part. Okay, so if I decide to paint this object, the entire hemisphere will receive paint. Okay, you can see that the entire hemisphere will be painted. So the surface area, okay, the surface area will be composed of the total area of the hemisphere, which is 2 pi r squared. Now we have to be very careful when it comes to the cone, okay? Because if I paint this entire object, what we must realize is that the only part that will get the paint, or the only part that I will be able to paint, is this one, okay? The slant part. In other words, this circular base is on the inside of the shape, okay? Because it's on the inside of the shape, if I'm painting this thing, it will be impossible for me to paint the inside of the shape, okay? Because this is a closed object. Hopefully you can see that. Now, because of that, we must understand that the only portion that we will consider in this formula is the slant part. Okay, so we cannot consider the pi r squared parts because it's inside. Okay, if we are painting it or we are wrapping it with something, the inside part, which is the circular base of the cone, will not be affected at all. Okay, so the total surface area of this entire thing will be 2 pi r squared plus pi r times the slant height. Okay. And then that being said, we can just plug in our value of r. Our r is 5, so it will be squared plus pi, and then we put 5 there. Now the slant height was given to be 13 centimeters, 13, okay? And then let's see what we get. 2 times pi, and then 5 squared plus pi times 5 times 13. Okay, so we get a value of 361. Okay, we get 361 comma 28, okay, centimeter squared, okay, because we are dealing with the area. Okay, so our final answer is 361.28 centimeter squared. Okay, so we are done.
We've come to the end of our session. Please like and share our videos with your classmates, friends, and family members. Ensure that you follow us on all socials at XYZ Math Tutoring, and don't forget to subscribe to our YouTube channel. I have dropped the link to our YouTube channel on the comment section. Go check it out. Have a great day.